Hello, my name is Spencer Stevens and I am Senior Vice President of Production Technology and Security at Movie Labs. The topic of this video is one of the most challenging issues I have encountered in my career in the media industry, and I've worked in production and distribution technology as well as production and post-production of movies and television for much of my working life. A perfect storm is a particularly fierce storm arising from a rare combination of adverse meteorological conditions, and it's also a great movie by Wolfgang Petersen. Production security is facing a perfect storm, and there are three conditions that are combining to create this storm. The first is the movement to cloud production and what that means for the way we create media. Movie Labs published its 2030 vision of the future of media production, and we are seeing many organizations aligning with that vision or expressing a very similar view. To understand the second condition, we have only to turn to one of the Cloud Security Alliance's own publications. Securing cloud infrastructure is complex. The third condition is a continuing increase in cybersecurity incidents, as can be seen by reading the Verizon Data Breach Investigation Report. That is happening despite the increasing sophistication of the tools that defenders have available. For many experts, this shows that the perimeter model of security, protecting the organization and its boundary, has failed. In the very beginning, production infrastructure was kept in a building with physical security such as locks and CCTV cameras. Media went into the building on film and tape, and it came out on film and tape. The walls and the security doors protected it. The internet offered the opportunity to improve workflows. For example, to transfer data between locations. But this came at the cost of the infrastructure being exposed to outsiders. The solution was a security model, the fortress model, which has much the same characteristics as physical security. There is a secure perimeter and with a gatekeeper, typically a firewall. The organization is in a fixed location, and security is predicated on the belief that everyone inside the security perimeter is a good actor and the bad actors are on the outside. But let's look at what cloud production looks like. Here we have cloud infrastructure, perhaps on multiple clouds, with workflows like camera to cloud and remote users connecting directly to the cloud, and other organizations working on a production sharing its cloud infrastructure. Cloud production isn't contained within a single location, nor is it only accessed by users directly employed by the production. The most obvious things about this diagram is that everything is happening outside of the security perimeter. Cloud production infrastructure is too complex to extend the security perimeter around it. So perhaps in a particular case, it might be possible to use a traditional security perimeter, but it will be complex, and complexity is the enemy of security. Besides, we cannot ignore the elephant in the room, which is that security perimeters don't keep intruders out. And given the number of security breaches where employees participate either unwittingly or deliberately, we can't trust those inside the perimeter that we might wish to view as good actors. In 1460, James II of Scotland opened fire on Roxburgh Castle with his brand new siege cannon, signaling the beginning of the end for medieval castles. The fortress security model is already headed down that same road to oblivion. The COVID-19 pandemic has accelerated aspects of the Movie Labs 2030 vision. People are working from locations outside of their offices, and workflows that historically were disconnected or had limited connection are now well connected. In the 2030 vision, we will shift from moving the data to the application to moving the application to the data. This means that infrastructure is shared with users, both employees and contractors, with vendors, remote production locations, and so on. Workflows are flexible, reconfigurable, and global. They don't have an inside and outside. and they are not in a fixed location. Cloud production. The premise of the fortress security model fails on three grounds. Good actors are on the outside as well as the inside. It's no longer about fixed locations, and you cannot be 100% sure bad actors are not on the inside. And that's universally true for any connected environment. There is a solution. It requires that we reconsider the assumptions that we make about the infrastructure. As you'll see, if you read the Verizon report, bad actors are getting into infrastructure that has been secured. That means that we should begin with the assumption that the security of the infrastructure has been compromised. And as a working assumption, it's certainly better than assuming that the infrastructure hasn't been compromised. That assumption is the basis of the Zero Trust security architecture. In Zero Trust, nothing is automatically trusted. A computer isn't trusted because it's connected to a particular port on a switch or because it's connected through a VPN. A user isn't trusted just because they're using a computer that is trusted. A 2019 publication from the US Defense Innovation Board stated that a Zero Trust access policy had been used in the NSA's network. Snowden would have been unable to obtain the broad range of documents he released to the public. And that is true with almost every breach where someone was assumed to be trustworthy because they were inside the network. Our goal must be to secure everything on an untrusted infrastructure. This diagram reflects the NIST Zero Trust architecture. At the center is a subject using a system to access a resource. However, the subject and the system are untrusted until the policy enforcement point has determined that they can be trusted to access the resource and allowed to do so by a security policy. There are many ways of looking at the characteristics of a Zero Trust architecture, but they come down to authentication and authorization. Trust has two components. The first is whether something is trustworthy, and that's a risk assessment issue. In a blog post, we use the analogy of a cardiac surgeon. Before you trust a cardiac surgeon to operate on your heart, you check their credentials and their success rate. The second component of trust is whether something that claims to be the thing you trust is actually the thing you trust. Is the person behind the surgical mask that's standing over you holding a scalpel the surgeon you were expecting? And that's authentication. So, in Zero Trust, everything must be authenticated, and that includes users, systems, and services. And you could take it further and authenticate software. Now, it's important that the authentication is mutual. When you connect to your bank's website, your browser authenticates the server using its certificate, and the bank's web services authenticate you by the multi-factor or passwordless method it uses. However, there are three parties in the transaction: you, the bank server, and your computer. And your computer has not been authenticated to the server, so the server is talking to a computer that has not been authenticated. Zero Trust requires mutual authentication. Of course, just because something is authenticated and can be trusted, it doesn't mean it should be allowed to do anything. Zero Trust requires that only authorized activities can take place. The authorization, which includes confirmation of authentication, is at the point of action or consumption, for example, where data is read. Authorization is conveyed in policies. Zero Trust security is not new. In 2009, Google responded to a significant security breach of their corporate infrastructure by implementing BeyondCorp, a Zero Trust solution. And recently, that has become a product on Google Cloud. In 2010, John Kindervag of Forrester Research described the Zero Trust model in what has become a seminal publication. But many of the principles and methods of Zero Trust go back long before those. The NIST Zero Trust architecture document is the reference people generally use today. Let us look at how we go about implementing Zero Trust. And I've taken these steps in a presentation by John Kindervag, and it's a vendor-neutral way of approaching the problem, which means it does not start with one vendor's definition of how to implement it. The first step is defining the protect surface. The protect surface is around the thing you are protecting, which is what the attackers are after. Now, this is not the same as the attack surface. Defining attack surfaces is a useful tool for risk assessment, but that doesn't have the same goals as security. In this photograph, we see the US presidential limousine making its way down a street in a US city. The security goal is to protect the president. Clearly there is a crowd, but the Secret Service isn't trying to secure the entire street, and that's a good thing because there is a large crowd with high buildings. It would be impossible to guarantee that someone wishing the president ill didn't slip through. So let's look at the uniformed officers standing along the street. Now, some of them are looking at the crowd, others looking at the president. It's cold, and they've probably been standing there all day. They're there to create the illusion of security, because while they might stop an ill-prepared individual, they're not going to prevent a serious threat. The Secret Service is focused on protecting the president, who is inside the limousine, and that vehicle is their protect surface. And if they can protect it successfully, they have fulfilled their mission, whatever else happens on the street. Their resources are focused on the protect surface. It's protected by the Secret Service agents walking alongside the limousine, those inside it, and those in the SUVs following behind, and by the limousine's armor and other defensive measures. You can see that there is a lot less inside the protect surface than there is on the street, and that's the model we need to adopt. Earlier I said that you can't be sure you've kept intruders out of your infrastructure, and this is the same thing. The Secret Service and the law enforcement officers can't be sure that there aren't any bad actors in the crowd. So the Secret Service takes measures that will protect the president even if there are. We define protect surfaces by determining what data needs to be protected, which are the applications that consume sensitive data, which assets are the most sensitive, and finally, which services can be exploited to disrupt operations. And those are the things we need to protect. The second step is to map our workflows. Now, I believe this is one place where we have an advantage over other industries, because those building the workflows are connecting to those using them. In other industries, that isn't necessarily true. An IT department knows that people use the email system to send messages, but they are not aware that the attorneys in the legal department are using their email folders to track contracts, at least until they implement a rule that archives email to another system after 90 days. Step 3 is to create policies. These are statements of which authorized entity are allowed to do what. Creating and managing policies might be automated or it might be manual. Step 4 is implementing the policy enforcement points. These are the components that sit between the untrusted and whatever is being protected, and interpret the policies to permit authorized access. Notice I said permit authorized access. I did not say deny unauthorized access. Zero trust is denied by default. Everything should be secured so that the default state is deny, which is why I didn't need to mention it, except to tell you why I didn't. And finally, we use analytics and monitoring. These should already be part of any security system. And in Zero Trust, we are not just looking for abnormal activity, we're also seeking to identify normal activity. The academic papers Google published on Beyond Court explain how knowing whether an activity is normal can be used to infer a level of trust, meaning that the trust isn't binary. I might say that in some circumstances, I'm not going to trust you to do everything that I will trust you to do in other circumstances. If you log on from the same location that you always do, I'm going to assign a higher trust value than if you log on from somewhere you never do. Or in some cases, I might not let you log on even if you have the right credentials. Once you understand how you will implement Zero Trust, you have to decide how to deploy it. The first instinct is often to start with the most sensitive data or systems. After all, those are the things that are most important, the crown jewels. Now, unless you have deployed Zero Trust before, I strongly recommend that you don't do that. The problem with going straight to the crown jewels is that these are often the parts of the system that are used only by a few people and might not be as well understood as others. And those are the parts of the system where it's likely that if something goes wrong on the deployment, well, you can complete that sentence. The fact is that Zero Trust is new to many people, and not many people in your organization, if any, will have experience deploying it. And unless you've done it before, deploying Zero Trust has a learning curve. As you can see on this diagram from Palo Alto Networks, the place to start the deployment is learning on the protect surfaces that are least sensitive or critical. Once you've done that, once you have learned, the more critical protect surfaces can be addressed. These are the ones where what was learned is now practiced. And it is only once that you've done that do you reach the point where the most critical protect surfaces can be addressed. And once you've done that, then the rest of the protect surfaces can be addressed in whatever time frame you have. So the deployment process is learn, practice, deploy. Zero Trust implementation can seem to be a daunting task, but with the right approach, deployment can be easier than it initially appears. John Kindervat quotes a client as saying, "We spent more time arguing about Zero Trust than we did deploying the first Zero Trust environment." In this video, I hope I have shown you that we can use Zero Trust to solve the challenges of securing cloud production. Thank you for watching.